Okay, so Alessandro Volta, he developed the first battery, and he converted what kind of energy into what kind of energy? Chemical to electrical. 1 mark for each. Okay. Number 2, by running an electric current through a wire near a compass, Oersted that electrical energy could have magnetic effects for 1 mark. Okay, Seebeck invented the first thermocouple, showing that blank could be converted into blank. Thermo means heat, and he turned it into electrical. Okay, so 1 mark for each of those. 1 mark for heat, 1 mark for electrical. Okay, number 4, when 2 atoms of hydrogen are forced together under great heat and pressure to form 1 atom of helium, what has occurred? Nuclear fusion. I would accept just fusion. Okay, if they just wrote fusion, that would be fine. Number 5, an avalanche has what kind of energy because it is moving? Kinetic. I would also accept mechanical, as if you have kinetic, you have mechanical energy. Okay, and an avalanche also has potential energy because it's obviously somewhere up a mountain. So I would accept kinetic, okay, and mechanical there, okay, since it did indicate because it is moving. All right, number 6. When Wile E. Coyote holds an anvil above the Roadrunner, the anvil has what kind of energy because it is above the ground? Potential energy. Number 7. What was one of the names used for energy before the 1890s? Living force would be one of the answers I would accept. And what's the Latin term he gave? Vis viva. I would accept that as well. Okay. Any others that anyone wrote down? No. Okay. Number 8. Who showed that mechanical energy could be converted into heat? Yes, Rumford. Okay. If they wrote Benjamin Thompson, that was his name before he became Count Rumford. Okay, we would also accept that. All right. And number 9, when you climb a flight of stairs, what kind of energy are you using? No, you're converting this energy into kinetic. No, you're converting this kind into mechanical. Chemical energy. You're using chemical energy. Your food that you ate is what powers you up the stairs. If you were starving, climbing stairs would be much more difficult. Okay? Chemical energy is the source of all of the energy that goes on in your body. Okay? Thus, it is chemical energy we are using. We are turning it into kinetic and mechanical. All right. So we had how many questions that were out of 2 there? We had 1 that was out of 2. 2. So we're looking at a mark out of 11. Okay, so give them a mark out of 11. Let them see it, and please come up here and put it in the box. Okay, so big thing here, guys. Scalar quantities. Okay, scalar quantities are things that have only, okay, a magnitude. All right, and by magnitude I mean they only have like a size in units. Okay, so mass is a scalar quantity, right? Yet no one says that they have a mass of 75 kilograms south, right? Your mass is how much of you there is. So, okay, that doesn't have a direction. That's just a number. All right. Same thing with distance. Okay, how far you have traveled does not worry about which way you have gone, because you could go around and around and around in circles, end up where you started, and still have traveled a very long way. Agreed? Okay? Your car does this all the time. And that was the example I used in the podcast, was your odometer, okay, the thing that tells you how many kilometers are on your car or truck or whatever it is you drive, okay, tells you the distance that car has been traveled. It does not tell you how far it is from where you bought it. Because if it told you that, it would read the same number every time you came home, which would be great in terms of selling it. because it would look like it has like 4 kilometers on it. Okay, but if it's not very good if you're the person buying it, as it could have 400,000 kilometers on it because you've probably driven it a long way. All right, everybody follow me on that. All right, so when we say how far something away or something is away, okay, we're saying just how far. We're not saying what direction. All right, other example, time. Okay, time is a scalar quantity because as far as we know, it only goes one direction. Okay, time only goes forward. So we don't put a direction on that. Okay, we don't say it was, 5 days south, because that doesn't make any sense. All right, it was just took 5 days to do something, or it took 2 hours to do something. All right, now, unfortunately for us as North Americans, we do treat time like it's a vector quantity sometimes, because we're really messed up in how we give directions, and I talked about this in the podcast, right? Okay, we as North Americans screw this up all the time, because we say Lethbridge is 2 hours south of here. Really? Time goes south. As far as I know, it doesn't. Okay, but that's what we tell people because we express distance in how long it takes us to drive somewhere. All right, which is really, really messed up. That's not a proper physical way, okay, to describe something, because under ideal driving conditions, yes, it might take 2 hours to drive to Lethbridge. Under January snowstorm, zero visibility driving conditions, it may take much longer than that. Okay? If you have a police escort, it may take considerably less time than that. Right? It's all those kind of things that are all factors in how long it takes to get somewhere. So we should always be careful about describing how far away something is by telling people how long it takes to get there. Right? Because that is variable. Right? Lots of things can affect how long it takes to get to a place. Right? But the last time I checked, Lethbridge is still the same distance from Okotoks. That has not changed. Okay? Everyone follow me on that one? We want to give them numbers that don't change or are not dependent on something else. Okay, and vector quantities have magnitude and direction. All right, so displacement. If I say that by walking from, this classroom to the office, okay, I have traveled roughly 45 meters at, let's say, 30 degrees west of north. Okay, I've told someone how far and in what direction I have gone from point A to point B. Okay, do I have to walk further than 45 meters to get from here to the office? I do, because I can't walk in a straight line from here to the office unless I can walk through walls, which would be really cool, but I can't do it. Okay? I actually have to walk down the hall, turn the corner, walk through the atrium, turn the corner again. Okay? I probably have to walk 56 or 57 meters to get to the office from here, all right? Because I can't travel in a straight line 35 degrees west of north in order to get there. Everyone follow? Yes? Okay. Velocity is a vector quantity, okay, where speed is a scalar quantity. Right? The speedometer in your car tells you how fast you're going. It does not tell you what direction you are doing that in. All right? And like we said in the podcast yesterday, no one's ever gotten a velocitying ticket. Okay? If you are going too fast for the road, you get a speeding ticket because you have gone faster than the allowable speed. If you are going the wrong way on the road, that is a separate ticket. Okay? You do not get a ticket for going in excess of the speed limit in the wrong direction. You get 2 tickets and probably get your license taken away. Okay? Generally, they don't like you going 140 southbound on the northbound Deerfoot. Okay? You probably wouldn't last long enough to get a ticket anyway. All right? So things like that to think about. All right. So does everyone understand the difference? Yes? Okay. How did we do with the algebra? Moving the equation around. Okay? All right, let's review, okay, the algebra of how that works here. All right, so if I've got this formula here, okay, and I'm going to put it back to its original setting, okay, like so. All right, we got V equals d over t. Now this could be speed equals distance over time. This could also be, if I had the little arrows over it, velocity equals displacement over time. Okay, the manipulation is the same. There's really 2.5 rules to algebra. Okay, I think I told you this back when we did the mole equation. Now kind of the other half a rule is going to apply. Okay, the first rule is that if you want to move a variable, you do the opposite. All right, so if I'm multiplying, I'll divide. If I'm dividing, I'll multiply. If I'm adding, I'll subtract, etc. Okay, you get the idea here. Right? The other thing is, what you do to one side, you have to do to the other. So if I multiply one side by t, I have to multiply the other side by t. Everyone with me there? Okay, and that's that we review from the mole equation. All right, now, when you're moving variables, okay, move what is not attached to your number first. All right, that's not going to apply for v equals d over t because everything is attached. But you are going to get formulas, okay, where you do have things that are not attached because you're going to have pluses and minuses as well as multiplication and division. Okay, you always move what is not attached first. Sometimes it makes more sense to people if I tell them, do your order of operations in reverse. Okay, how many people remember order of operations? Okay, you do brackets, right? Then you do exponents, then you do multiplication and division, and then you do addition and subtraction. Does that make sense? Okay, so usually we consider something to not be attached if it is not being multiplied or divided. All right, so if it's being added or subtracted, it's not attached. Okay, because you would write there would be a symbol in between. When we multiply things together, we put them side by side. Everybody follow me on that? So in this equation, in this equation here, A and D are attached, okay, because they're being multiplied together. They're written right beside each other, right? But VI is not attached to this whole term here because there's a symbol in between. All right, so that's what I mean by not attached. Essentially, it means if you're adding or subtracting, you do that part first to move those things, then worry about the multiplication and division. All right, now that's not going to apply to us for a while yet. Okay, for v equals d over t, we don't have to worry about that, but those are the rules for algebra. Okay, when we're looking at v equals d over t, if I want to solve for d, I need to get d by itself. All right, I mean that's kind of the rules of algebra. You want to find something, isolate it. So right now, I'm dividing d by t. I want d by itself, so what do I have to do to move t over to this side? I need to do the opposite, which is multiply. All right, so if I was writing out the whole thing, which obviously we wouldn't do very often, okay, I would multiply this side by t. I have a t on the top and a t on the bottom, so they cancel. Okay, and then I have to multiply this side by t because rule number 2 says what I do to one side, I do to the other. So now I've solved for d. Okay, d equals v times t. Everybody all right with that? Okay, if you're ever in doubt as to whether you've manipulated something right, you can always plug the units in and see if you get the right units. Right? The units for distance would be like meters or kilometers or something like that. So let's say I was given a speed in meters per second, and I was given a time in seconds. Okay? Well, seconds times meters per second, what happens to the seconds? They cancel. That leaves me with the units for distance, so then I know I did my manipulation correctly because I got the units I was looking for. So if you ever need to double check, you can do it that way. All right, so let's go back here to our original setting. Okay, and I don't need that anymore either. All right, let's say I want to solve for t. This is probably the trickiest manipulation of this formula. If I solve for something, does it need to be on the top of the equation or the bottom of the equation? It needs to be on the top. Okay, here's why. A lot of people will look at this equation and say, I need to get t by itself, so I'm going to divide both sides by d. Okay, which logically means sort of correct. Okay, but if I divide both sides by d, d divided by d is what? 1. So that leaves a 1 here. Okay, and then the d is gone. Okay, over to this side now. Right, so I've got 1 over t equals v over d. Is 1 over t the same as t? It isn't. Okay, here's why, guys. If t is 5 seconds, okay, 1 over t is 1 divided by 5 seconds, which is not 5 seconds, it's 0.2. All right, so those are not the same thing. All right, everybody follow me on why they're not the same thing? Okay, so let's go back to the manipulation then again. All right, So I've got v equals d over t. I want t by itself. What did I do when I wanted d by itself? I moved t, right? When I moved t, did it end up on the top? It did. All right, so that's the first thing I'm going to do. I'm going to move t. All right, I know that seems weird because I want it by itself, but I need it also on the top, and right now it's on the bottom. All right, so I'm going to multiply both sides by t like I did before. So I have t times v equals d. I want t by itself. What do I do with v? Divide both sides by v. All right, again, we're just following the rules of algebra here. I want to move something, I do the opposite. All right, so I divide both sides by v. Okay, v cancels here, and I've got t equals d over v. All right, essentially you just kind of cross multiply or flip the two. Everybody with me there? Yeah? Okay, how far did we get on the worksheet yesterday? What's that? A few questions, 2 or 3? Okay, why don't we go through the first 3 questions on the sheet together, okay? Just so that we kind of see how those work. All right, this was the first one, right? The jogger question. Okay, whenever you're solving one of these questions, the first thing you want to do, just like you did with the mole equation, is write down your givens. 1, because you're going to get a mark for that. 2, because it helps you figure out which formula you're going to use. Obviously, right now, there's only one formula you're going to use, v equals d over t. But later on in this unit, when we've gone over like 25 formulas, writing down the givens is really helpful because it basically eliminates lots of formulas for you. All right? If you are given mass and speed and asked to find energy, you're not using v equals d over t because that doesn't have mass in it. All right, so writing down givens will really help you pick formulas. Okay, how far? What am I looking for if the question tells me it wants how far? Distance. All right, so I know right off the bat, distance is my unknown quantity. All right, so I'll be solving for d in this question. How far does a jogger run in 1.5 hours if his average speed is 2.2 meters per second? All right, there's a problem with this. Hours and seconds measure the same thing in different ways. Can I use them together in a mathematical formula? No. Okay? Dividing one apple in half does not tell me how many oranges I have. Would you agree? Okay? I can't compare apples and oranges. Okay? These things may both talk about time, but they don't talk about time in the same way. All right? So, what I need to do is make my units match. All right? I have 2 options on that. I could change the speed to meters per hour, or I could change the hours to seconds. Which one sounds easier? Hours to seconds, absolutely. How many seconds in an hour? 3,600, right. A lot of you are going 60, 60, 60. I know, because I was thinking the same thing the first time. Okay, so it's 3,600 seconds. 60 seconds in a minute, 60 minutes in an hour, 60 times 60. All right, so in 1.5 hours, okay, I'm going to go 1.5 times 3,600, because that's how many there are in 1 hour. Okay, and that'll tell me how much I have. So that'll be 5,400. 5,400 seconds. Okay. I know I have to use this formula. V equals d over t. Okay, now, sorry, back to this idea here. This isn't going to happen very often. It's most certainly not going to happen on a test. I wouldn't throw something like that at you on a test. Okay, but just know that your units do have to match up before you can do any mathematical operations with them. Okay, all right. So v equals d over t. I'm trying to solve for d. What do I have to move? T. Okay, I want d by itself. So I'm dividing by t, so I'll multiply both sides by t, make it cancel over there, and make it come over here. Now I can plug in my numbers, just like I did with the mole equation. D equals 5,400 seconds, the time, multiplied by how fast this person runs. Right? And this should make sense, right? if they can go 2.2 meters in a second, multiplying by how many seconds I have should tell me how far I go. Right? That sort of makes sense logically. Okay, and that's going to be 11,988 meters. Okay, do I need a direction on that? No, because it asked me how far. The question never mentioned which way they were running. Okay, it gave me a speed. Right? That doesn't tell me which way they're going. It just tells me in any direction, basically. If they were running this fast in 5,400 seconds, they would go that far. All right? If they were running north, it would be north. If they were running south, it would be south. But we don't know which way they're going. Okay? Everybody with me on that one? All right. Okay, for number 2, with an average speed of 67 meters per second. All right, so one of our givens is speed. How long does it take a falcon to dive to the ground along a 150-meter path? Okay, anything in meters has got to be distance. All right, and that's something that we have to understand when we're reading a question. We need to know what units represent what. Kilometers, meters, centimeters, whatever is all measures of distance or displacement. Okay, meters per second, kilometers per hour, any of those always represent speed or velocity, and obviously time is going to be in seconds or hours or minutes or whatever. All right, so we're looking for how long it takes. So I'm looking for time here. Do all my units match? They do. My speed's in meters per second, my distance is in meters, so my units match. All right. So V equals d over t, but I'm looking for time. All right, time right now is on the bottom of the equation, and I can't leave it there. If I want to solve for it, it has to be on top. So the first thing I want to do is move it to the other side, where it'll be on the top, by doing what? Multiplying, right? All right, so I multiply both sides by t, and t comes over here. I want t by itself, so how do I move v? I divide by it. Okay, again, first rule of algebra, do the opposite. Okay, and then what I did to this side, I have to do to this side. So t equals d over v. Right? Which should make sense. We do this thing in our heads all the time. If we're driving somewhere, we try to figure out how much longer it's going to take to get there. We take how far it is and divide it by how fast we're going. Okay, if the sign just said it was 150 kilometers to Edmonton, and you're traveling at 100 kilometers per hour, we mentally know it's going to take an hour and a half to get there. Agreed? Okay. So when I plug in my numbers here, time is going to equal, okay, 150 meters divided by how fast the Falcon is diving, 67 meters per second. Right? When we do that, we should get 2.23 seconds. All right. Everybody okay with that one? Right? So those are the two manipulations of v equals d over t that you'll be asked to do. Right? Obviously, you don't have to manipulate if you're looking for the average speed. Okay, and then we'll look at number 3 here, and then I'll have you guys work on that a little bit more and go over any that give you trouble. Okay, now the wording for number 3 is what makes number 3 tricky. Okay, number 3 is actually asking you to treat the two parts of the world record trip separately. Okay, the first time you're just dealing with the trip to the right, and the second time you're dealing with the trip back to the left. All right, so the driver makes these 2 runs. Okay, one in each direction. The car first travels from left to right and covers a distance of 604 meters in 2.19 seconds. All right, the car then reverses direction and covers the same distance, okay, in 2.22 seconds. All right, so I'm treating each run separately because it says here, from these data, determine the average velocity for each run. All right, in this first part, he went from left to right, which means this is not a distance, it is a displacement. It has direction. It told me he went from left to right. Okay, so that means he went 604 meters right. In the second run, he went 604 meters left. Okay? I want to find the average velocity for each run. So the first thing I've got to do is indicate that both of those are vector quantities by putting the little arrows over top. Now it's displacement, not distance. Doesn't really change the math. Velocity is displacement over time, which is still the same formula, they just have the arrows over top. Okay, so the velocity is displacement, 604 meters, divided by the time, 2.19 seconds. All right, I don't have to manipulate. Those are my givens, and I'm asked to find v, so that's nice. Okay, so for the first one, we get 276 meters per second right. Okay, I have to give a vector because I was finding a vector quantity. For the second part, same idea. Okay, velocity is displacement over time, which is going to be 604 meters left, okay, divided by 2.22 seconds. All right, when I do that, I should get 272 meters per second left. Whatever direction you end up traveling is the direction your velocity will have. They have to be the same. You cannot end up, let's say, travel 100 meters north by traveling at 67 meters per second east. Would you agree? It is impossible for that to happen. That's why the two are always going to have the same vector on them. All right. This question doesn't ask this, but I am. What's the average velocity over the whole trip? Okay, remember, velocity is your total displacement divided by your total time. Okay? This person went 604 meters right. So here's their starting point. And then they went 604 meters left. How far are they from where they started? 0. Okay? Their total displacement is 0 because they're back where they started, which means their average velocity is also 0. Okay? Here's why. Velocity is displacement divided by time, and we just said this number is 0. Well, anything, 0 divided by anything is 0. I don't even have to calculate what the total time is if I know the person didn't end up going anywhere. All right, you guys follow me on that one? That's where the vectors can kind of have a little trick sometimes. Now, the other part of that could be, what if I asked you to calculate the average speed over the whole trip? Okay, what we have to remember there is that speed, average speed, is total distance over total time. They went 604 meters right, then they went 604 meters left. How far did they go? 1,208 meters. Okay, remember, direction doesn't matter because distance and speed are, starts with S, scalar. Right. Okay, so my total distance is 604 plus 604, not caring what the direction is. Okay, on this one, okay, it was 604 right plus 604 left. Right? Positive 604 plus negative 604 is 0. Okay, so that's kind of how that works differently. Okay, and then I had 2.19 seconds for the first run and 2.22 seconds for the second run. So what I have is 1,208 meters in total divided by 4.41 seconds. Everybody with me here? Okay, so if you have a trip that has more than one part, you have to add the parts together. Okay, you're looking for total distance and total time. All right, so if I did that, 1208 okay, 1208 divided by 4.41, that gives us 273.9 meters per second. Okay. All right. I want you guys to work on that worksheet for a little bit, okay? And then we'll go through a few more here. In about 10 or 15 minutes, we'll go through a few more of those, okay? You're done the whole sheet. Okay, try the back. Okay, down on the back, direction matters. So you'll have some left, some right, right? You'll have to put directions on. Okay, let's have a look at number 4 here, guys. So number 4 is another example of one of those questions that has 2 parts to the trip. All right, so we want to find the average, well, it says average velocity, but it's really the average speed because we don't have any directions in there, and I accidentally left velocity and all that in there. Okay, so we're going to travel 11 kilometers at an average velocity of 21 meters per second. So that's part 1. Okay, so the distance in part 1 is 11,000 meters. Why am I converting it to meters? Right. Okay, the velocity, in this case, it says velocity, but it's really just a speed because it doesn't give a direction. So I forgot to change some of the terms. This used to be a vector question, and then I changed it to just be a scalar one. Okay, so 11,000 meters, and my speed is 21 meters per second. Okay, then in part 2, it travels 1 kilometer, so that's 1,000 meters. Okay, at a smaller velocity, speed of 4.2 meters per second. All right, we want to find the average velocity of the bus for the entire trip. Okay, sorry, average, just the average speed of the bus. Okay, average speed of the bus. Okay, over the entire trip. So here's what I need to do. If I want to find average speed, I need 2 things: total distance and total time. The total distance, that's no problem. I was given how far each trip was. Okay, so my total distance traveled here is 12,000 meters. Okay, so that part's easy. But I don't have the time for either section. How am I going to get those? Do I have the other 2 parts of v equals d over t for both part 1 and part 2? So can I find out how long part 1 and part 2 take? I can. Okay, so this is just a multi-step question. It's just asking you to use v equals d over t a couple of times, okay, to solve this question. So the first thing I've got to do then is find time for part 1. Right? When I manipulate v equals d over t for t, it's t equals d over v. So I've got 11,000 divided by 21. All right, so the first part takes me 523.8 seconds. All right, so that's good to know. Okay, second part, got to do the same thing. T still equals d over v. I've just got a different d and a different v. All right, so 1,000 divided by 4.2. Right, is 238.1 seconds. All right, so now I'm going to do the same thing on the bottom. 523.8 plus 238.1. All right, so my overall average velocity, okay, is going to be 12,000, okay, divided by and whatever that comes out to, so plus 523.8. Right, divided by 761, okay, so we'll have 12,000 divided by our answer for that operation. Okay, so we get 15.8 meters per second as our average speed. All right. How many of you, be honest, when you did this question, went 4.2 plus 21 divided by 2 to get the average? Okay? And that's fine. I know more of you did it that way, but okay? That's fine because that's what you've been taught to do to calculate averages. Here's the problem with that. While that is correct in some situations, it isn't correct in this situation. It's correct if I'm calculating the average, the class average on a quiz, because every one of you represents an equal part of the total. So I would add all your marks together and divide by the number of people. Okay? In this case, though, this part of the trip represents a much greater percentage of the trip than the other part. Would you agree? Okay? It would be like saying this. You traveled to Edmonton from Okotoks, and for 250 kilometers, or let's say like right before you got to Edmonton, like let's say a kilometer before Edmonton, you had to slow down from 120 to 30 because of construction. Okay? Would you take 120 plus 30 and divide it by 2 and have an accurate representation of how fast you went on average between Okotoks and Edmonton? No way. Okay? Your average is going to be like 119 point something because that last kilometer is less than 1% of the whole trip. Agreed? Way less than 1%. Okay? We can't take those two parts and treat them like they represent equal halves of the trip. They're not. Okay? We use that expression all the time. It's like, oh, that's the small half. Well, then it isn't half. There can't be a big half and a small half. It isn't half. Half is exactly in the middle. Okay? You guys follow me on that? So whenever you're asked to calculate average velocity or average speed, you have to take total displacement, if it's velocity, or total distance, if it's speed, and divide it by the total time. All right? That is how we do that. Okay? With that formula right there. Okay? How many people have done number 5? Okay, let's have a look at number 5. Okay, sound travels at a constant speed of 343 meters per second in air. All right, and that's at like about 20 degrees Celsius, so room temperature. Right? Approximately how much time in seconds does it take for the sound of thunder to travel 1,609 meters, which is the equivalent of 1 mile? All right, so we want to find out how long it takes sound to travel 1 mile. So we're told the distance is 1,609 meters. We're told the speed of sound is 343 meters per second. I'm looking for time. Okay, so V equals d over t. I'm looking for t, so I multiply both sides by t. T comes over here. I divide both sides by v. V comes over here. All right, so t equals d over v. 1,609 meters divided by the speed at which sound travels, 343 meters per second. All right, so we take our 1,609 and we divide that by 343. Okay, so it takes 4.69 seconds for sound to travel 1 kilometer. Right? You probably did this as a kid and you wanted to figure out how far away the lightning was. You counted. Okay, how long it took for the sound to get there, and generally we say you divide by 4. Okay, and that tells you about how many kilometers away it is. Okay, and it gives you that. All right, everybody follow me there? Yeah. Sorry, you don't divide by 4, you multiply by 4, and that tells you how far away it was. All right, so we get 4.69 seconds. So it does take quite a while for sound to travel that far. I mean, you probably noticed that even sometimes when you're out, like here in the school grounds, you know, you can notice that it takes sound a little while to travel. A track meet is a great place to find that. Like whenever the starter's pistol, right? You can sometimes see the smoke, and then like an instant later, you finally hear the bang of the gun, right? Just because it takes sound a while to travel. Okay, those kind of distances. All right, let's keep going on that. I'll give you a few more minutes, then we'll look at number 6. You may. Okay, let's have a look at this one here, guys. So on this question here, we've got a car that's traveling at 27 meters per second. okay, which is around like 100 kilometers an hour. Okay, so we got v equals 27, okay, meters per second. Okay, the driver looks away from the road for 2 seconds to tune the radio, or in your guys' generation, that would be to text your friend while driving, which is stupid. And I'm going to show you why. Okay? So you look away for 2 seconds at this speed. I'm going to show you how much road you miss. That is, how far you travel in that 2 seconds while you're not paying attention. Because this is like my big pet peeve. I'm ready to weld pipes all over my truck and run texters off the road. Take justice into my own hands. Okay? All right. So, I want to find the total distance traveled. V equals d over t. And I'm solving for d this time. So, I'm going to multiply both sides by t to get d by itself. The time is 2.0 seconds multiplied by 27 meters per second. You miss 54 meters if you look away from the road for 2 seconds. 54 meters is a long way. A really long way. All right? If you do that in a school zone or a playground zone, you will run over someone's child eventually. I say that in all seriousness. I do not say that facetiously. If you are a person who texts while driving, especially with your inexperience behind the wheel as 16-year-olds, you are a deadly weapon on the road. Okay? Please keep that in mind. Your attention should be focused on the road when you are driving. Your text messages can wait. All right. Tomorrow, we will be working on some more v equals d over t stuff, but I'll start talking about the vector part of this and when direction matters and all that kind of stuff. Okay? We'll be moving on to graphing probably before the end of the week. Oh, also guys, I think I've reminded you of this, but I'll say it again. Final exam schedule is out. That's been in the announcements, but it came off today. Remember to check that schedule. Your science one is June 19th, Friday. Okay? At 9 o'clock in the morning, I would assume, in the gym.